own knowledge is made of 10 years of experience regarding drones to manage and command platoons and batteries, support, logistics, and operation within the regiment. I gained my main operational experiences in Central Africa Republic in 2017 and in Mali and Burkina Faso in 2021. What matters the most regarding the actual conference, the current conference, are the 3 months I spent in Mali. 3 months actually deployed in operation in the desert with the UAV system. Far from any operating base, and from January to June 2021, I was in command of a multi-sensory intelligence group engaged in Mali. The drone system was therefore employed in combination with electromagnetic sensors and human intelligence teams. My mission was to collect intelligence and build targeting files about Islamic State and Al-Qaeda branches in the region. Please note that all over 2021, the UAV system Spy Ranger made 250 missions on French Barkhane operation. A few words about the context. Several points of view. First of all, the drone range used in Mali and the place of the Spy Ranger in it. So you can see it circled here in green. It was used from the single kilometer range to the theater white thanks to the Reaper, French French Air Force Reaper, and the satellite imagery capabilities. This complementarity of means is quite important. You can guess that every system has its own fields of expertise. The Thales systems meets the necessary renew for the French Army of the segment, drone segment previously armed by the DRAC system, and it fits the demand of modernization. Modernization continuously required to collect information faster and more accurately. A few words about the climate. Desert conditions are especially tough. The temperature amplitude is huge. It was from 10 degrees to here. Pictures are mine or my men's to 64 degrees Celsius. During my operation, the 3 months one in the desert, the 80 flights were performed. We made 2,000 kilometers with the system embedded, for transportation between Mali, Niger, and Burkina Faso. Something important to notice. The Spy Ranger system was deployed in Mali from January 2021. It was not the final version of it made by Thales, but what we call the minimal operational version. What are the differences? You can see them here. The user interface was a bit different. It has been reviewed since we made a comment about it. In-flight limitations. We were not able to use it with the rover system. I mean, we were not able to use it with the from a vehicle in movement, and there was no laser pointer when we used it last year. All these specifications should be integrated by Thales with the final version. Specifications. Nonetheless, it has some things in less. The specification were completely matched. These are images I took directly from Thales website. The system is operated thanks to a ramp. To put it briefly, the specifications are 3 times better than its predecessor. It launched thanks to a ramp. We performed regarding the record 2 hours and 54 minutes operational flight and reach up to 35 kilometers range with no loss of data links. The gyroball definition is pretty impressive and stable. I figured on the Thales website that it exists a bigger version. I used here, if you can see, the 330 and not the 550. Within the weight of 15 kilos is included a 5 kilo battery. You can program also, thanks to the user interface, geofence to set up a box dedicated to your mission. What is not specified on Thales website is the capabilities of the UAV regarding identification and detection. So you can detect any vehicle from 1,500 meters and clearly identify it within the range of 500 meters. I won't give any element about places or time to keep the document unprotected. What about the storyboards? Storyboard 1 I'd like to show you. It's about target acquisition. So as the system was placed on call, the alert rank. It was given by the indirect fire detection system of the base. The UAV quickly reached the coordinates, and the circular error probable is good enough to deliver mortar harassment firing quickly. Also, we were able to make the BDA, battle damage assessment, quickly, thanks to its accuracy and the definition of the sensors. Storyboard 2, terrain reconnaissance. Please note that it's on daytime, so 4 days before the mission, the drone mission, we collected information about IED in the vicinity of our settlement. We got the information not thanks to the drone, but thanks another sensor. The road was quickly identified after a few days, and we got information more accurately about the axis to monitor and to get information about. So this time it was thanks to the endurance of the UAV, we were able to go along all over the axis and clearly identify the bypass which was used by the enemy to avoid the known position of ID by the population. Thanks to that, day after, we were able to send the engineer to clear the axis. Combined effect. As we were in the desert, we got sensing of a lookout, a small team giving intelligence about our own movement. The drone was in flight and we were able to retask it very quickly and to reach the coordinates and give them finally to the desert battle group, infantry, but desert battle group, which was around the position. They were able to neutralize the enemy quickly. Main capabilities on this tasking were the flexibility and the responsiveness of the system. I will now show you a short video made by the regiment. I will try to comment it in live. This short film demonstrates the quick setup of the system with a well-drilled team. You can see the terrain is quite rough with rocks and dust. You can imagine the worm. All along the many setups we performed, we got really few broken parts, easily replaced. Anyway, the system is really robust and made to be easy to maintain. The crew operates the UAV thanks to a single terminal, which is wired console with a wired console controller. So it's really easy for any soldier to use it in flight and to be able to retask it on any objective. The few video rush you can see just after have been voluntarily downgraded because to avoid any localization of the picture. Electro-optic sensors and then night sensors, infrared. To conclude, the system has fully satisfied my requirement in replacement of the former system. During the mission, it has been operated easily and sometimes under high pressure in high pressure circumstances. Spy Ranger was a reliable asset during that long and difficult mission. If you have any question, I will be happy to answer if I can.
lost? Oh, sorry. Have you lost any UAV during the operation, or no loss to declare?
We lost no UAV. We just had one broken part was the GPS on the GPS antenna, which suffered from the heat, but it was exposed to the sun directly during the long mission of 2 hours and 54 minutes. That's it. It was quickly replaced, and there is no loss to declare anymore.
Yes, you mentioned a laser pointer that was not on the optronics. You have other capabilities on the drones, like laser designation?
Not on the one I used, but it's planned to be implemented by Thales. I can say more about it.
Hello, and on that kind of mission, how many drones do you have? You have only one, or you have different type?
No, the system is delivered with 3 UAV, and for the mission, for the 80 flights within the desert in 3 months, we used 2 only to transport, and we had 1 in the Gao base in spare. It was not necessary to engage the spare during the mission.
Yes, just one precision about the question about the laser on the SMDR, the UAVs. I have currently these capabilities. Just is not already qualified by the DGA. It's a different type of problem, but it will be qualified for the further versions.
Hello everyone. I am Captain Pellerin. I'm second in command of the 3rd Battery of the 54th Artillery Regiment, specialized in air defense. I came with Corporal Thomas, who worked on operation on the Milad, which is the system I will present you today. So I'll present the fight against drones, and I will focus on the feedback of the use of the Milad, which is an anti-drone system. Okay, so first off, I will briefly introduce you to the MAV threat, which stands for Mini Aerial Vehicle. So basically, that's the mini drones that anyone can buy in any retail store. So from now on until the end of the presentation, the term drone will refer to the mini aerial vehicle. So these tiny drones that you can see on exhibitions on many of the stands here. Secondly, I will share with you my experience as an officer in charge of the 3D means and what challenge I had to face when dealing with this menace. And then I will show you how this new device, the Milad, solved many of the problems we had prior to its deployment. Next. So, okay. So first off, the MAV threat. So for maybe the past 5 to 10 years, it has become an almost normalized course of action to use these drones for many kind of usage. So I will not elaborate on this part, so it will be brief. So they say a picture is worth 1,000 words. So here's what you can do with this kind of drone. So on the left, you have a drone carrying a couple of 40mm grenades. It stands above its target and just drops its payload for maximum damage. So these pictures are not graphic. You can find literally dozens of them on the internet. You don't need to look very long to find them. So this is what it does on a vehicle. And this is what it does on troops. Again, I selected a few pictures that were not graphic, but just look on the internet if you're looking for the effects of this kind of stuff. So they are both used by state and non-state actors. Wherever you go in any theater operation, you will find this type of drones for this kind of usage, and has become a normalized threat. So they can be used for, dropping payloads, of course, but also terror attacks. You can equip them with an IED, an improvised explosive device, and just make them explode in a bunch of people. They can be used also for more discrete means, that's intelligence, but also to direct artillery fire, for instance, and that's what they're used for, mainly on the theaters of operation. Okay, so next is the limits of countermeasures. So when I was deployed as an artillery officer abroad, I was tasked on several occasions to implement procedures to counter this threat, or at least limit its effect. So I will show you how hard it turns out to be without specific equipment. So first off, a little case study. So this is a soldier on duty, is tasked with the surveillance of an operating base. And given at least that he managed to stay focused for 8 hours straight, which is much more than I can do, he'll have to watch the sky. And at some point, he sees a tiny black dot. So this is what goes on in his mind. What am I looking at? Is this an aircraft in the far distance? Is this simply a bird? Or is this indeed a drone? Well, it can't really say without proper equipment. And when I was on operation, and prior to the use of this equipment, I had literally dozens of reports every week of drones. Most of them were wrong, of course, but there was no way we could say. And since I couldn't say, when it happened to be really a drone, I couldn't really tell. So I'll get back to this case study in the end, but when I was asked to implement these procedures, the first thing that went on my mind was the speed of action. So to improve the speed of action, I had to first find a way to detect and then write down procedures which narrows down the reaction time to the minimum. So of course, if you happen to see a drone, first you'll have to confirm what you've seen. You'll have to determine its distance, its type, report and raise an alert, which is very hard since they are so tiny. And when the alert has been raised, you got to deploy a unit to shoot it down or to neutralize it, and then secure the area. Because when you have such a device in the middle of a camp, for instance, you have to consider it just as you would consider an improvised explosive device. So the conclusion, my own conclusion at least, while developing this procedures, was that there was no efficient procedures, or at least they were too slow to be efficient against MAV without proper equipment. So what equipment have we got prior to the deployment of specialized equipment? Well, my unit was equipped with the NC1 radar, which is a very efficient means to detect aircrafts, and the M3 Mistral missile. Okay, what can we do with these? Drone, MAV, has an almost insignificant or inexistent radar signature. So regular radars aren't capable of detecting this threat. Then for the identification, my men were equipped with a Sandra camera, and they were specifically trained for aircraft detection and aircraft identification. As an example, they could sometimes identify an aircraft up to 20 kilometers. For a drone, it could be, well, at several hundred meters, they couldn't tell the difference really. So that was not the proper equipment for it. And again, the heat signature is extremely low, so of course, well, you can call me Captain Obvious, but you can't fire such a big thing on such a tiny piece of device. So, of course, a missile is an overpowered asset for this kind of threat. Well, I think I'm going to give up on these papers because. Okay, and now let's look at the regular countermeasures. So maybe you know about all arms air defense. When a unit which is not equipped with air defense weapons has to defend itself against an aerial threat, they will apply what we call all-arm air defense procedures. So basically that's using their own equipment, rifles, guns, whatever, against the flying threat. So first off, we all got our 5.56 guns, 5.56 rounds. So anybody who's acquainted with shooting with a rifle knows how hard it could be to shoot down such a tiny thing at 100 meters high. So it's basically impossible, or it can happen by chance, but it's not really the best thing. What do we got here? A 20 millimeter gun. Same things apply. Too big and not enough against such a tiny thing. So we even thought about the 12-gauge shotgun. So 12-gauge shotgun could be a solution, but happened to have an effective range of 50 meters. Let's say 75 meters with ball trap rounds, for those of you who practice ball trap. But again, that's not the solution. So what happened is that we were equipped with a nail rifle, which is a jammer, very efficient one, particularly useful as a light mean. But we still had to solve all the other issues. So we solved the neutralization part, but we still didn't have anything for the detection, so for identification, and to narrow down the reaction time, basically, because the reaction time will be narrowed only when the problem with the detection will be solved. So without specific means, again, we are too slow. So now let's get to our main topic, the MILAD, and how the MILAD system solved all these issues with the procedures, especially. So for those of you who are not acquainted with the tongue of Molière, it means it's moyen intermédiaire de lutte anti-drone, which means anti-drone medium-range defense system. So it can be subdivided into three parts. There are three subsystems: the sensors, the command posts, and the jammers. So first off, the sensors. So first part of the MILAD system is the sensor mast. It can provide radar detection and a 360-degree day and night imagery. That's basically it. It sends its picture to the command post. So there is a radar picture. Unfortunately, I couldn't find any unclassified picture because most of them were pictures of ongoing operations. But basically, that's a screen, a map, and whenever something is detected, there's an alarm that rings, basically. And second part is the video camera, which sends its picture to the command post, so the operator can directly check what was detected. And that's what my buddy right here did during his deployment. And now the last part, the jammers. So there are 4 jammers for one system. So they are implemented in a way, well, they provide 360-degree directional jamming, and they can, which means they can jam directly at the target without frying everything that's around. So it's directed. And it has proven efficient up to 1,700 meters in Mali. We don't know if there's a limit. Well, at least this is the limit we have seen on operation. We managed to fry down one drone at 1,700 meters. So what happens when a drone is jammed is that it either stands above its position, it cuts the link between the operator and the drone itself, so it will just stand idle until it finally lands, or it can cut its GPS signal and it will fly undirected until it falls down, or again it could simply get back to the last known position of the operator. So when we've neutralized it, we can then apply our procedures to terminate it. So let's get back to our case study. So our operator right there has an alarm that rings on his computer. So he checks on the picture. He sees a drone. Okay, doesn't have much time. Maybe it's a friendly drone, maybe not. Probably it's not. So in just a click, he can jam it, block it, report to his superior, and they can decide on the course of action. So this time it will be neutralization and termination. Okay, so now we managed to find a solution to all the issues we previously had. The visual spotting and is provided actually by the radar itself. The identification and distance determination by the cameras. And reporting and raising the alert can be done directly at the command post because it's usually located within the HQ of the forward operating base. And as for the reaction time, since you can jam it instantly, it reduces to, well, instant action actually. You can have plenty of time once it's jammed to decide whether you're going to terminate it or leave it alone. So the MILAD is comprehensive enough to provide solution to all the issues hereby cited. So what about its deployment in Mali? Its mission, well, the missions of the operators there, was to participate in the protection of the FOB 24/7. That includes detecting and jamming any threatening MAV, just as I showed you, or raising the alert in case of imminent threat, but also to concur in the detection of any threat, any kind of threat around the camp. Because since it's based on movement detectors, it can detect different kind of activities, unknown personnel roaming around the base, or anything else. Okay, so 2 systems were deployed in Mali in 2 different bases. And our feedback was it was eventually proved efficient for drone detection and also useful for detection of other moving targets, just as I said prior to this slide. And it also helped keeping permanent surveillance around the base, since the motion detector could tell us if there was some unusual movements around the camp. It also proved very helpful to give clear reports on the situation around the camp, and eventually it proved very efficient, or reliable at least, because they've only had few system breaks during the whole time it was deployed. So still, since it's very new, we still had some improvements that we soldiers thought would be interesting to implement to the system. The first one is the implementation of a dedicated maintainer. That's not a problem about the system, that's much more of organizational, because we didn't have any trained technician. So the operators had to do all the repairs themselves. They managed to do it, but they would have gained more time if they had a technician with them. The whole system was very reliable, steady, solid, but the jammers, if handled too much, could break their seal. So given the weather in our theaters of operation, this is one other improvement that we proposed. And third one is increasing radar sensitivity and target discrimination. Since when we had a lot of movement around the camp, it sometimes detected things that were not threats. Well, this is more of a... that was the job of the operators and the officers in charge to discriminate whether it was a threat or not. But we would have liked a better sensitivity. And last point is the implementation of full spectrum jamming capability. Since when we had a threat, a confirmed threat, we had to choose on which channel we wanted to jam it. Well, that would be preferred if we could jam it on every frequency at the same time. So it would help us get more time for the rest of the procedures. Okay, the advantages we got from using this system, it requires only a short training for the operators. I don't know combien de temps t'as été formé dessus? Okay, only the operator right here was trained only 2 weeks and could use it during the whole mandate without any problem. It was easy to set up, easy to use, easy to maintain as well. As I told you, we didn't have any dedicated technician, but they had no problem repairing themselves the system. It was steady and reliable, very few system breaks during the whole time during which it was deployed. And eventually it proved very efficient and it narrowed down the reaction time to almost instant action. And that's what we initially wanted. Now this concludes my presentation on the Milad. And but we're still working on new solutions for drone detection and anti-drone systems. So I just presented the Milad. Another system under development, the Parc, should enhance our capability in our anti-drone capability, basically. There's also the individual anti-drone system. We can divide anti-drone systems in three parts: base protection systems, individual, and mobile protection systems. So as for the individual anti-drone system, I presented the NEROD during my presentation. This is the rifle-like thing on the right picture. It should be enhanced with the implementation of an individual radar. So there are concepts that are being drawn as of today. They didn't come out yet, but they should be in the future. And the last part, and the focus of the French Army, will be on mobility, with a capacity, an all-arms anti-drone capability, which should be represented by the RLAD. The RLAD is the system on that armored vehicle. So this is basically a radar with a 40mm gun that can fire grenades, fire shrapnels in order to shoot down drones, and a specialized anti-drone capability. So just like air defense, that would be for specialized units, and that would have the capacity to, just like air defense, to coordinate with other means, with joint means, and etc. Okay, that concludes my presentation, my feedback on the Milad. If you have any questions, I'm here to answer, and my comrade, Corporal Thomas, is here to answer them as well. Yes?
Thank you. So regarding the Armad program, so it's using 40mm automatic grenade launcher. Meanwhile, the Griffin turrets have a 12.7 machine gun. Is it planned to switch some of the? So does it make sense to use the current Griffin turrets for anti-drone, or do you need the RLAD version with the 40mm?
So your question is it better to use the 40mm grenades or the 50 cal, basically? Well, it depends on the precision, of course. If the 50 cal is able to aim at the target precisely and shoot it down, I think that both will do. Then, as of choosing one or the other, I can't really tell. It depends probably also on the range. I think I'm not giving an absolute answer, but the grenade launcher maybe will have a shorter range with a higher rate of with higher precision and on short range, and maybe the 50 cal will be able to shoot targets further, but without the explosion and the shrapnel. So we'll see what the studies of the army will lead to.
Thank you for the presentation. Do you have any way of integrating all the solutions you presented, both present and future, into a single system, for instance, the Scorpion system, to share information and have different effectors actually treat the threat?
Well, I think that's the final objective, is to be able to coordinate all of them. One system. I think the best option is to have, well, several systems, but all coordinated within a single chain of command. That would help us, just as we do in air defense, for instance, to select which means is better suited for the threat that you have to deal with at the moment. So I think best thing is have several means deployed, and the chain of command can coordinate all of that instantly. That would be the best way to use this new anti-drone system, well, this new solution for anti-drone. So coordination is very important.